We started discussing the half wave rectifier. Here we have a single diode and a resistor, and we put a sine wave here, and the diode will only allow positive side of the waveform to pass through. So you get an output which is something like this, right? Positive half of the sine wave will be passed through. It is not necessarily a sine wave, but since sine wave is available, I am talking about sine wave. Any waveform, positive side will be allowed to pass through. So this is the V out, and this is V in. So the voltage across the resistor will be 0 for T by 2 to T, and outside 0 to be 0 to T by 2. So the average value of this how much? One of the assignment problems, Em by pi, where Em is this peak value. Okay. So we get this much amount of DC out of the sine wave with a peak value equal to Em, we get Em by pi. But in addition to this VDC, you have this minus this is a junk, right? So this is not DC, so this creates problems to us. It is not a pure sine output, pure DC output. So this, that is V out minus VDC, is some signal called a ripple signal. Ripple. So this ripple is undesirable. We want to avoid this, but we would like to get a measure of this, how much is the ripple value, and see how bad this supply is. We normally require the ripple to be not more than about 0.1, 0.01, 0.001% of the DC. Compared to that kind of requirement, we look at the ripple, what you will get here. If you find the RMS value of the ripple, is equal to 1 by T, 0 to T, V ripple square times G, which is equal to 1 by T, 0 to T by 2, because the other half is 0, half V out T square dt minus plus VDC square integral 0 to T by 2 1 by T dt minus 2 times 1 by T integral 0 to T by 2 V out T into VDC into dt, right? This is expansion, square expansion. So this will come out to be equal to what? For the first is equal to nothing but this. This value is equal to Something gone wrong? This should be t. Since it's 0 to t, that also will be 0 to t. So, this will be equal to 1 by t because VDC is a constant here, you pull this out. So, you get the same thing as VDC into this, which is again a VDC. So, this becomes VDC square. So, the 2 minus 2 VD square, this becomes equal to VD square. So, there will be a minus of VDC square. Now, how much is this equal to? Without much calculation, you should be able to say this is nothing. V out is a sine wave, half sine wave, and this is integrated for the half value. Full value, you know how much is RMS square is equal to V max square by 2, and since only half is now there, it becomes another half. So, it becomes equal to Vm square by 4, right? Because all the both half cycles is equal to Vm square by 2. Since the integration is only half cycle here, another half will come. So, you get Vm square by 4 minus VDC square, which is Vm square by pi square. I am using the different symbols. Vm square. Okay. So, this will be equal to, this is the Vrms square. Vrms square of the ripple is equal to this, which is Em square into 1 by pi, 1 by 4 minus 1 by pi. By pi square is it? Something wrong?
RMS for half wave is max by 2.
No. For sine wave, full sine wave, it is Em square by 2. Right? RMS value is M by root 2. So, square of that will be M square by 2 and another half of that. So, that will be equal to M square by 4, and VDC is equal to Em by pi. So, Em square by pi square. So, this becomes to 1 by 4 with 1 by pi square. So, the ripple Vrms of the ripple is equal to square root of into Em agreed, and what is VDC equal to Em by pi. So, if you compare this with respect to VDC, the ratio comes out to be 1.21. If you do this calculation, so it's a very bad power supply. In this sense, the ripple is a 1.21 times the DC, and I said normally we would like this to be some very small fraction of the DC value. So, this is a very bad number. I must somehow decrease it to a much less value. We will come to a method of doing it as we go along, but right now let us accept this is not a good power supply. The second thing is, if you expand this half sine wave in Fourier series, which also we have done in one of the assignment problems in the assignment number 1, it has a DC component which we already taken care of. In addition, it has a first fundamental, second harmonic, third harmonic, so on and so forth. The fundamental will be at the same frequency as this. If this is 50 hertz, the fundamental will be at 50 hertz, and the second next one will be 100, so on and so forth. So, the next problematic wave in this would be the fundamental, because it goes down, the harmonics will go down as 1 by n square. So, because of that you will find out that the other component, second harmonic, third harmonic, comparatively negligible compared to the fundamental. Not negligible, but small compared to the fundamental. But fundamental, if you take it, it is occurs at 50 hertz. If you intend to filter it in a simple minded manner, you will require a very large values of filtering circuits, values will come to that, and usually filtering 50 hertz is a difficult problem at power levels. So, we will find some other ways of how to get rid of this ripple or reduce the ripple to as low a value as possible. But before we go to that, we will go to full wave rectifier as against half wave here.